continuing on with Chapter 19 notes, this is page 532. So we use petroleum not just in our cars, but in so many ways in our homes. And it's plastics, really. So the majority of our plastics, I mean the vast majority of our plastics, comes from petroleum. Now we have the technology to make plastics out of other things like corn actually, or rice, but they're not as common as what's made from petroleum oil. So do know, I mean, just make sure you look over this and realize that petroleum oil is used in so many products, not just in gasoline. But to be honest, the majority of petroleum is used in gasoline. Okay, so are we running out of oil? Yes, kind of. So we have peak oil. So the concept of peak oil is that we can increase our production and then at some point we start to decrease the amount that we can get out of the ground. And so a guy named Hubbard predicted in the United States when we hit peak oil, and he was actually correct. And in the world, we believe we just got past peak oil, and so every oil that we get now is deeper in the ground and harder to get out. Now, some of our reserves have increased as we have new technology to get it out of shale and out of tar sands, but those are more expensive options. And so oil just will get more expensive as time goes on because it's more expensive to get it out of the ground. It's deeper, it's harder to extract. Page 534, we have primary versus secondary extraction of oil. So primary is basically just send down a pump it out of the ground. Secondary extraction means that the oil is embedded into rocks and you have to crack the rocks. And so in this oil rig platform, they inject seawater to crack the rocks. So high pressure water cracks the rocks and then they can get the oil out of the cracked rocks. And so this is called fracking, and so we developed the fracking technology really for extracting oil first, but now we use the fracking technology primarily in the United States for natural gas. And so you can see here on the next page, we have a fracking configuration on somebody's farmland here in the middle of the country. This is in Pennsylvania. So a lot of farmers have given the rights on their farming land to fracking companies because they got a lot of money, thousands and thousands of dollars to allow it. But the problem is that, here's the problem. Okay, so it's called fracturing techniques, but it's really called fracking. And what we do is we pump water, sand, and chemicals into the rocks to crack them and extract the natural gas. Here's the downside, is that often the gas gets into well water. And so now these people living on their farms, their wells are contaminated with not just natural gas, but other chemicals as well, because the chemicals can contain all kinds of horrible things that would cause cancer and all kinds of horrible problems to the body. But the fracking companies do not have to disclose by law what they're using, and so a lot of times these people are getting chemicals in their water and they don't even know what they are because the companies don't have to say what they are by law. It's called proprietary secrets. Another problem is that fracking uses huge amounts of water, and in some places like California where they want to start fracking, we don't have any extra water for fracking. Earthquakes ? Because it's not 100% sure, but it's about 95% sure that the earthquakes that are being caused in places like Oklahoma that never had earthquakes before until fracking started about 10 years ago. And now they have this huge amounts of earthquake. So is it a cause and effect? So the data is almost certain, but not quite, that it is a cause and effect. Of course, the gas industry is fighting it tooth and nail, saying, oh, these are just natural earthquakes. But there's a lot of research by universities coming in that, yeah, earthquakes are being caused by fracking. So if we get methane out of the ground and there's a leak, it can cause it is a greenhouse gas for global warming. And then habitat fragmentation with roads to the sites that hurt species. And then you have wastewater piles. So as the water is being used to crack that rock, some of it becomes wastewater, and then what do we do with it? So these are all the problems with fracking. Okay, page 537. So we use fossil fuels. So how do we address their impacts? How do we try and minimize it? And this is on page 536 here, addressing the impacts of fossil fuel use. And so with coal, we learned some of these before. So clean coal techniques clean coal is a term that's used by the coal industry to show, hey, we're not so bad for the environment. This is what we do. So some of these we know. Wet scrubbers remove sulfur dioxide. Electrostatic precipitators remove particulate matter. There is some research into something called gasification of coal, which is claimed to be less harmful. And then carbon capture and deposit underground is still experimental, and they want to know, they're trying to figure out if they can do that without causing earthquakes or other problems. So can we capture that carbon instead of putting it in the atmosphere where it causes global warming? Can we send it back underground? Because initially, those fossil fuels came from underground. So here is the technology that is proposed for carbon capture. Again, it's experimental at this point. Well, it's technically theoretical. I don't believe anybody's doing it yet. People are trying to get permits to experiment and see if it works, but a lot of places don't really want it to be experimented where they are. But so this is a possibility in the future. So we'll see. Some other impacts are oil spills. So here's the oil spills you need to know about. We've studied the Deepwater Horizon in Chapter 16. And then we had the Exxon Valdez that occurred in Alaska, and know of the impacts of the oil spills, including what happens to species. And on the next page, page 540 and 541, it shows the impacts of the Gulf oil spill down here and how much oil was spilled and where it went in the Gulf of Mexico. And all of the problems that it caused and how they researched what's happening with species down there. And it's not even just habitat, it's also fisheries. So thousands of people fish in the Gulf of Mexico for their livelihood, and that's an important thing. Page 542, some of the other impacts of fossil fuels is how we mine for coal. We'll study more about mining in Chapter 23, but this is mountaintop removal. It's pretty awful. This is in the Appalachians, a lot in West Virginia, Kentucky, and the people living there are not happy about what's happening to their landscape. However, there are some people that like it because it does provide jobs. How does oil extraction alter the environment? Well, roads to drilling sites cause habitat fragmentation. This is the main one. So if you're ever asked about the environmental impact of oil drilling, this is it. When we build homes by the oil sites or pipelines or waste piles, those also can damage habitat for species as well. Okay, and then these are the problems with coal mining. So coal mining destroys habitat. We saw mountaintop removal, but other types of mining do the same thing. Causes soil erosion, acid drainage. So this is a chemical runoff of sulfide that comes from the mining process. Mountaintop removal causes the clogging of streams and rivers with debris, and this debris is called overburden. Underground mining causes black lung disease for the miners. So a lot of coal mining companies are kind of going away from subsurface. They still exist all over the place, by the way, but the miners themselves don't like the underground because it's more dangerous. So all of these kinds of things are external costs, which means they're not factored into the price of coal, and coal is therefore cheap. If we really had to pay for the cost of the health care for black lung disease and we really had to rebuild these mountains, you might see the price of coal going up, which people wouldn't like because then the price of electricity would go up. All right, go to page 546. So now we have energy efficiency and conservation. So how do we as a country reduce energy in order to extend the supply of fossil fuels? Because things like oil will eventually run out or become so expensive they're cost prohibitive. Coal is actually not going to run out for a while. We have reserves for another 100 to 200 years of coal, but coal is extremely bad for the environment. Okay, so one thing that we can do is we can raise CAFE standards, which I'll talk about in the next sticky note. You can buy a car with high miles per gallon yourself. You can insulate buildings to prevent loss of heat or air conditioning. So our school is like that, has a lot of energy efficient windows and insulation. Energy Star appliances and better lighting like fluorescent light bulbs. Cogeneration is where we take the heat produced by one item and we use that to, or one process like factory, and we use that to generate electricity. It's called cogeneration. CAFE standards are the minimum miles per gallon of a fleet of cars per company that, that they can have. And so it promotes fuel economy and it lessens air pollution and greenhouse gases. And so these are the CAFE standards. Now it stands for Corporate Auto Fleet Emissions, but we just call it CAFE. You also need to know what baseline power is. So baseline power isn't really talked about in your book, but you need to know it. So baseline power means that there needs to be this constant flow of electrons in the system so that when you turn on a light, your light goes on. If you had to wait for the power plant to go, oh, you would like electricity in your house, and then they burn some coal or they let some water through a hydroelectric dam or something like that, then you would have to wait several minutes before the electricity got to you. So we keep this constant flow of electrons running through the wires at all times so you can turn on an appliance when you want to turn on an appliance. And so this is called baseline power. And coal and nuclear and hydroelectric power are good for baseline. Wind and solar are not because they're a little more inconsistent. One of the problems with our power system is about half of the electricity that we generate is lost in the wires. We have a really old wire and electric system. And so we need to update it with a smart power grid that would save energy and reduce greenhouse gases and air pollution. So why don't we do this? Well, it's the political will of the people. We're basically going to have to use tax money to update our entire electric grid in the United States, and people don't ever want to vote themselves more taxes. But if we did and we updated our power grid, then we could all end up saving money in electricity costs. Okay, so page 548, how do governments promote energy conservation? So on an AP exam, on an FRQ, there are things the government can and cannot do. Our government, because we're a democracy, cannot just ban coal. It cannot just ban fossil fuels. We can do certain things, but we cannot just ban things as the government. We can provide tax breaks or rebates for energy efficient appliances. We can do things like allow cars in a carpool lane, hybrid cars or electric cars. We can raise CAFE standards. We can subsidize alternate electricity like wind and solar. Those are the things that we can do. We can't just ban things. And then on the last page, know these terms. They're not in your book, but what OPEC is it is a group of oil-producing countries in the Middle East that all get together and ban. And then we in the United States have a strategic petroleum reserve that is kind of a reserve of fossil fuels, of oil in case of an emergency. And we store it into caves. It's kind of interesting. All right, that's the end of chapter 19.